2. And theorem 2 talks about angles in a circle. Angles in a circle. The angle that an arc of a circle sustains at the center is twice that which it sustains at any point on the remaining part of the circumference. We are going to prove this theorem. We are going to prove it. Now, to prove this theorem, we say draw a circle with center O. Draw a circle with center O. Now, we call here A. This is our B. Let's call here P. Now, we draw a line from this place, from this point to here, and we'll call here Q. Remember, here is our O. Now, from this theorem, we can say that OA is equal to OP. Reason they are radar. And then we should take note that this part of the triangle AOP is an isosceles triangle. AOP is an isosceles triangle. So we can put here as S2, here will be Y2, here X1, and here will be what? Y1. Now, if this part of the triangle is an isosceles triangle, it means that S2 is equal to X1. It means that S2 is equal to X1. That is, this place is equal to this place. The reason base angle of an isosceles triangle are equal. Base angle of an isosceles triangle are equal. Now, we can also say that AOQ, that is the angle that is suspended here, we say AOQ is equal to S2 plus S1. AOQ is equal to S2 plus S1. That is, this angle suspended here is equal to S2 plus S1. What is the reason? We say external angle of an isosceles triangle. External angle of an isosceles triangle. External angle of an isosceles triangle. Now, we can also say, since our S2 is equal to S1, since S2 is equal to S1, we can simply say that AOQ is equal to 2S2. We can say that AOQ is equal to 2S2. We can say that AOQ is equal to 2S1. Also, now we see that we have two triangles here. We have this side and we also have this side. We say this side is an isosceles triangle. This side is also an isosceles triangle. Whatever applies to this part of the triangle also applies to this side. Now we can say that BOQ, that is the angle here, BOQ is equal to Y2 plus Y1. That BOQ is equal to Y2 plus Y1. Now, if Y2 is equal to Y1, therefore we say that BOQ is equal to 2Y2. BOQ is equal to 2Y2. But we need to find the angle here. That is, the angle that is suspended at the center of the circle. So the angle at the center of the circle, we call it AOB. That is, angle AOB. The angle that is suspended at the center of the circle. Now, we say the angle at the center of the circle is equal to AOQ. That is, this angle here, AOQ, plus BOQ. That is, this angle here. We say BOQ. Now, if you look at what we discussed here, we can see that AOQ is 2S2, BOQ is 2Y2. So, we simply put here as, we say that our AOB is equal to 2x2 plus our BOQ is equal to 2y2. Now, something is common here, which is what? 2. 2 is common. So we say our AOB is equal to 2 bracket S2 plus y2. Now, our S2 plus y2 is the angle that is here. That is the angle that is suspended at the point on the circumference, which is this angle here. So we simply say that our AOB is equal to 2AB, that is 2AB. So we can see that the angle that is suspended at the center of the circle, which is AOB, is equal to, is 2 times the angle that is suspended at a circumference. So the next thing we are going to do, we are going to be looking at some examples. We will solve some examples on this angle in a circle. Example 1 on angles in a circle. Find XOZ and XYZ. Find XOZ and XY. In this circle, if you look at the circle, you see that this point is given as 33. That is, we say that XW is 33. How do we find XOZ, which is the angle? So we say that XOZ is equal to 2 times 3. Why? Angle sustained at the center is twice the angle sustained at any point on the circumference. So we say that our XOZ is equal to 2 times 33. So our XOZ is equal to what? 66. 2 times 33 is what? 66. And they also say we should find XY. Now our XYZ will be equal to, first of all, get this angle here. We have already gotten this one as what? 66 degrees. So to get the angle here, we now say this angle here will give us, that is XOZ, that is this angle here, will be equal to 360 minus 66. Reason, sum of angle at a point is equal to 360. That's why we're using 360 minus what? 66 to get the angle that is here. So now 360 minus 66 will be equal to what? 294. I've gotten this angle here. 294. So to get the angle here, remember we said that the angle sustained at the center of the circle is twice, which is sustained at any point on the circumference. So to get our XYZ, simply say 294 divided by 2. That is, this angle sustained at a point on the circumference. So 294 divided by 2 will give us 147. So the angle here is 147. We've gotten that our XOZ, that is this angle here, 294. Then, for us to get the angle here, we simply say 294 divided by 2. That is, the angle that is sustained at the center of the circle is twice that which is sustained at any point on the circumference. So we divide it by 2 to get the angle that is sustained here, which is 147. Now we'll be looking at example number 2. Let's go to example number 2. Angles in a circle. Example 2. P, Q, and R are points on a circle. P, Q, R are points on a circle with center O. This is the center O. If OPQ is equal to 36, what is the size of PRQ? If OPQ, the angle here, is equal to 36, what is PRQ? That is the angle here. What is PRQ? That is the angle here. Now, we say solution. If OPQ is equal to 36, it simply means that OQP is also equal to what? 36. That is, if here is 36, it means that here is also what? 36. Reason, base angles in an isosceles triangles are equal. Base angles in an isosceles triangles are what? Equal. So if here is 36, which is OPQ, if OPQ is 36, it simply means that OQP will also be what? 36. Now, we have gotten this angle and this angle. What we need to do now is to get the angle here. That is the angle that is sustained at the center of the circle. So to get the angle that is sustained at the center of the circle, we say that our POQ, which is angle here, is equal to 180 minus, first we are going to add these two angles, minus 36 plus 36. That is 180 minus OPQ and OQP. That is 180 minus these two angles. Why? Because angle in a triangle is equal to 180. The sum of angles in a triangle is equal to 180. That is why we are subtracting. We are subtracting this by what? 180. Because the sum of angle in the triangle is what? 180. So we say that our BOQ is equal to 180 minus 72. BOQ is equal to 180 minus 72. How do we get this 72? 36 plus 36. The 36 here is OBQ, this angle here, plus OQP, this angle here. Remember, when we started initially, it was just this angle that was given, which is OPQ. The angle here was given. So how did we get this angle here? This OQP. Now we said we got this angle here because any angle that is here is the same thing that will be here. Why? We said base angles in an isosceles triangle are equal. That is to say, if here is 36, it means that here will also be 36. So that is how we got this 36 here. Now, so for us to get the angle at the center of the circle, we say the angle at the center of the circle is equal to 180 minus the angle in the base. That is these two angles here. So this will give us 180 minus 72. Remember, this 180, we got this 180 because the sum of angles in a triangle is equal to what? 180. So now we say that this will give us 180 minus 72 will give us 108. 180 minus 72 will give us 108. That is 108. To give us 108. 180 minus 72 will give us 108. Now the angle here is 108. The angle here is 108. But we have not gotten what they asked us. The question is find BRQ. That is the angle here. The angle we are asked to find is this angle here. So how do we get this angle? Now we remember our theorem, which is theorem 2, that says that the angle suspended at the center of the circle is twice the angle suspended at any point on the circumference. So which means that our BRQ will be equal to 180 divided by 2. BRQ will be 108, rather 108 divided by 2. That is the sum of angle, the angle suspended at center divided by the angle suspended at the point on the circumference. So 108 divided by 2 will give us 50.